So today we're going to be talking about architecting and orchestrating AI agents. As Sandra just mentioned, I am from various backgrounds within the traditional ML space all the way up to the current stage of AI. So you can say I was here before AI was really cool. I'm excited to teach you why AI is cool from the past into the present. So to the agenda today, for those of you curious, first we're going to talk a bit about why I'm capable about talking about this type of stuff. Then we'll talk about what AI agents actually are. And then we'll talk about the meat of this presentation, which is actually how to evaluate and improve agents before going through a recap and any next steps that you may want to take with us moving forward or for any questions that you have. So I just want to set the stage by saying GenAI is extremely easy to demo and it's hard to productionize. I don't have enough fingers to count the amount of GenAI demos I've seen on social media and or GitHub itself. I can count on one hand itself how many I trust to productionize and incorporate as part of my daily lifestyle, especially for mission critical tasks. So GenAI makes for a great demo, but it's not applicable until we can touch it to all of our other external software and tools that really make up the core of our own workflows or our businesses' workflows. Let me double check this. On the other hand, agents too are easy to demo, but they're even harder to productionize than the standard term of GenAI. The reason for this we'll talk about soon, but imagine taking all of the crazy workflows of standard LLMs and allowing it free reign to do whatever it wants. All I know is I had a rambunctious child myself. I don't think I let them go without a little bit of supervision here and there. So that's how we're going to teach ourselves how to be very pointed about how to treat this type of supervision. Don't trust me for it. Trust all of the different teams I have worked with personally as parts of Weight Devices, customers, different other teams building in the space, and our technology providers. And the reason that this is really important to talk about is I'd love for you to drop in chat too which of these personas you fall into. Previously, there used to be this term of foundational model builder and AI engineer that encompassed the degree of folks who represent the traditional ML mindset you have. So those who work with statistics, touch GPUs all the time, and are probably coding in some crazy CUDA layer that I don't miss touching myself. And those folks have a specific set of tools, techniques, and operations that they care about. They care about building models or adapting certain models that were spread across clusters of GPUs for their own particular use cases. Now we're in a state of the world where AI is a ubiquitous concept that any software developer can incorporate into their toolkit or their businesses. And so we go from this very particular niche of people who could only build these models into those who can use these models downstream to build AI-enabled applications. This also changes, though, how you should perceive the success criteria for software that touches AI. No longer are we living in a world that is simply unit tests that represent a state of success for code. If the code runs, that means it works. And that's a very proper mindset for standard software. But now we're in this 2.0 state of the world where LLMs are touching software, where LLMs themselves are inherently non-deterministic, aka the same input does not necessarily yield the same output. These tests are not appropriate anymore. And that means any software that touches an AI feature or uses an LLM in itself is now experimental by nature. We're not looking at unit tests anymore. We're in a collection of tests which hopefully have a statistical response that we can use to say whether or not this was a successful endeavor from incorporating AI into a software product. So no more binary pass fails. It's more over a collection of tests. Does it reach a success threshold? And so this also changes what's useful as you could develop on top of these types of workflows. For standard software, DevOps world, your code is your IP. Every time you check in some new code, it gets serialized into a place like GitHub. And that's how you know, one, your state of truth at that time. And two, that's what you sell or provide to your business to say, this is a unit of software that will do something useful for us always, and we can improve upon it from there. However, with AI development, instead, every experiment we run where we make a change to a model we use, change our prompts, change the workflow around how we touch this particular LLM or AI model, that in itself is actually what you want to serialize as you start to build up the proof that your feature that you're building in software is working. And so forgive me for being a bit prescriptive about this. This is very, I see a lot of confusion from software developers about this. So to make sure that this is extremely clear, that this experimental nature of LLMs is something that needs to be taken care of at the very beginning of any projects you build. And I'll skip over the slide. And so that opens up a bunch of new paradigms that exist. Prompt engineering, RAG, fine-tuning, agents, and inference are not something all of us can do regardless of our skill level or expertise in AI previously. So many of you are actually probably touching this prompt engineering stage. If you have gone into ChatGPT and pressed the edit button or copy and pasted an old chat thread and pasted it into a new one, you're prompt engineering already. What we're doing around that, though, is where prompts represent the unit of interaction between you, the user, and the specific AI-enabled software tool. We have built a lot of different workflows to make that connection of human language into action taken by LLM a lot easier or a lot more intelligent, I guess would be more appropriate to say. And regardless of any decision you make, be it search plus LLM, which is what RAG is, throwing new data at a pre-existing model architecture, fine-tuning, allow agents the autonomy to use tools and solve actions by given vague instructions, agents, or swapping out inferences providers between the various models as they improve across multiple model providers themselves. And so with this new paradigm, this also allows us to think about the LLM app development process in a much more streamlined fashion also, especially as ChatGPT and like tools have been out for a few days, for a bit longer than a year now. So I'll just hand wave and say, pre-training is something many of you will not be doing. That is taking the internet scale of data, making your own LLM. So for those practitioners who do develop those models, they are used to tools and dashboards like these, very statistical by nature, very experimental by nature. But for those of you who are not doing this pre-training or fine-tuning function, instead worry about the system engineering, aka using these models downstream for your business or application, that's really a new set of tools. And hopefully we can help provide those tools or make you understand the need for the processes that underlie these tools. So let's do some vocab right now. AI agents are a particularly contentious phrase to use, as there are many definitions that exist. For me, I'm going to just put a stake in the ground and say, moving forward, here's our definition, at least for the tenure of this presentation. They are autonomous AI systems that plan and execute multi-step tasks in a loop using memory and tools until a goal is achieved. So to decouple that from the pre-existing LLM chains that existed, so for instance, these RAG style workflows or the one-dimensional or it's like the one-dimensional workflow that existed previously, where you were given a input, very strict set of steps that you tell your LLM to do, you then provide an output. You can incorporate things like tools, external search engines, multiple steps, and a lot of other crazy ways to spread out how this inherent DAG is represented. But at the end of the day, there's a particular input that you've conditioned this workflow to be solving, and the output will always typically be a set of answers that you expect given that input itself. AKA, this is pre-described behavior you're building an application around. Agents, though, agents are a little bit more interesting. They exist to solve a class of problems. And so agents operate in a fashion in which they are given a collection of tools and tasks they're able to solve. But given an input, the LLM itself determines the criteria needed to solve that task, aka what steps it needs to take. And then also as each step is performed, it also reflects to understand, did this particular step lead me to what I understand is the goal state given that user input? So to kind of ground this and make it a little bit less theoretical, an LLM chain might be something like, let's say we have a travel assistant. This one chain might be only good at using the LLM to actually book the final flight after it's been decided. So let's say I want to go to Turks and Caicos this November. This chain may actually force me to put in the dates of the trip itself and the particular location. And then from there, it might do the steps of search Expedia, find the cheapest ticket, which is pre-described behavior, and then actually go and purchase that ticket. All of those are specific steps that I forced my travel assistant or travel chain to actually do. Now, a travel agent that uses an LLM as the brain behind the scenes, that one can be something as simple, can be a lot more vague. So I could say something like, book me a great island vacation for November. And what the agent's going to do is have to spend a second to think, oh, what does it mean to have a good island vacation in November? So they need to now balance activities that are meant to be done, cheapness of the flight itself, convenience of the flight given my current location, and etc. So in a similar vein as you would ask a friend for a recommendation, and their neurons are firing off to figure out what works best for you as the particular user itself, this is what the agent is also trying to do. Luckily, we can use prompts, words, and a lot of the fancy techniques to ensure that we direct our agent to think a little more appropriately, while also not lobotomizing it to the point where it becomes a straightforward LLM chain, which is able to only do one specific sequence of steps to solve a task. Feel free to drop in QA or chat if this is a bit confusing, but I just want to make sure that this definition is also clear. How LLM chains are different from LLM agents. DAGs versus free-form workflows that in itself determine when it should end by itself too. And so some key characteristics that really make agents different from these chains, again, are the ability to plan, aka decompose vague user inputs into sequence of steps that it can operate on. Tool use, which is ability to essentially call functions to proxy over specific behavior that should be taken, aka finding the best flight. It can be as straightforward as search Expedia with the filter of descending over cost. That is a specific action that an agent can take and understand what the particular outcome of that tool should be, and then read that outcome and make decisions. Memory is also a fascinating one because memory can be as easy or as complex for agents as need be. So example of non-complex agent behavior is the actual chat thread itself. If you're going back and forth with an agent, what you're doing is essentially create an in-context memory version of your whole conversation. That whole thread essentially is the state of your conversation as you make adjustments, where every time you continue that conversation with the agent, it's still using that whole conversation. Or you can do session or a cross-session based memory, where you have crazy behavior such as you're able to understand every thread one specific user has done and use that understanding across every chat that's been done with this user to inform future chats. AKA, if you were to go to ChatGPT right now as someone with a pro account or a login, the little memory section that you can go in your settings, and that's an example of how LLMs or LLM systems can save your overall preferences across agent sessions. Really useful as you start to build these user profiles up from the ground up as you understand your personas you're interacting with your LLM application. And then also reflection is a particularly useful one that really is the core of, or reflection plus goal orientation, I would say, are the core of the agent itself. They stolen straight from the RLM. Reflection, as the name implies, is the ability to actually go and perform these planned actions it takes using tools across memory to understand whether or not it's doing something that's useful. So it should be able to take an action and then take a pause, as many of us should be doing as we have conversations or do tasks, is do a step of that task, see if it actually brought us closer to finishing that task, or whether or not we should be pivoting from here. And so once but the thing is, as we reflect, it also needs to be conditioned across the goal that this particular agent is trying to solve for. So every step of reflection is the end result essentially is, am I getting closer or farther from my end goal as I understand it from my session of self-planning? I think that this is a really good example of how to decompose how an agent can be thinking. This you see right here is particularly the react pattern of thinking for agents. Agents live in a crazy world where there are a variety of different thought processes or thought loops that we can have our agent do. This, I think, is a great foundational way to think about this. An incoming query comes in from a user. The LLM must now take a second to plan the steps it may need to take. It takes that first initial step using a collection of tools, which may be interacting with memory, and then understands whether or not, oh, this should be a double-sided arrow, I do apologize. It then takes that end result from the tool itself, observes whether or not that brought it closer or not to the end goal, goes back to thinking, plans an action, and continues this process over and over until it understands in this final observation that, oh, I have reached the final state. I have all the information necessary for me, and I've decomposed the problem sufficiently enough to actually solve this particular user's query. So that signals the finish flag in itself that needs to stop, which can be as simple as a token or a giant caps lock or a letter phrase that says the word finish, for instance. But once it sees that signal, whatever it may be, then it spits out that final response. So this is just a way to think about how agents in essence really are just loops of LLM calls until it finds that final signal to then spit out an answer. I am going to hand wave this. This is just to say that, so from this thought loop, it's very different again from straight LLM prompt to answer, different from the DAG flow or also the RAG flow, where you have a sequence of pre-scripted steps into this fully autonomous system. So you also imagine how this is the natural evolutionary path that came for taking advantage of this inherent thought processes or and capabilities by LMs. And this also opens up a new set of behavior, which are multi-agent patterns. So what I described was one independent agent. However, we're now in a world where we can actually have a collection of agents that interact with each other in very interesting paradigms themselves, which of them have a particular task they're trying to represent. So over here, you see on the right-hand side, this is the actual code that you would need to write to use something like the QueryEye agent framework, a horizontal style framework, which I'll expand upon a bit in a second. But in essence, you can define agents in text a variety of different behaviors you want that agent to be able to perform. And then you also have tasks, which represent what that agent wants to do, given its inherent persona and the tools available for that agent in its specific state. So in essence, you can say a researcher agent, his only goal is to go and research, where the insight agent is able to do things such as read the data coming in from the researcher agent and build dashboards. Where the dashboards are then consumed by the content writer agent, who writes a blog against those charts that were made and embeds those charts into that content piece, where then passes off to the text formatting agent, which preps this particular piece of content for socials. And all of these can be independent agents that interact with each other. Well, Anish, why don't we just use one agent to do everything? Aren't LLMs so powerful and agents so cool? Great question, random voice that it also sounds like Anish. The reason we can't do that is that we also see that there's a weird scaling law or scaling behavior along with agents. As you throw more behavior, more tools, more text at agents, agents get a bit confused. Imagine you yourself are at a company and you're told that your job is to do marketing, but you're also told inherently to do all of this. If someone comes in with a vague task and you're told that you're able to do every single one of these things agent wants to do, or one super agent which can do all of these behaviors right here, then you can imagine how we'd get a bit confused about what that sequence of steps needs to be to actually solve what your boss would be asking the marketing team to do. But when you're able to decompose agents and tools into very pre-scripted behaviors themselves, then we go to something similar to these LLM chains that we saw earlier. The only difference is that the units of these blocks here are not a particular LLM call. Instead, it's a particular ask of an agent to do some deep thinking to come up with something that's appropriate for the next stage of processing. AKA, it's a way to really gain much more deep insight over your task and data, but still preserve qualities we like in software, which is DAG-like behavior. The ability to say, each of these agents do something in isolation and together can solve a multitude of tasks. Makes it way easier to debug also, which is something I want to imply over here as you split up all of your behaviors. And some popular agents I say with that definitively are useful and work, and you'll notice here that are non-mission critical, are coding, deep research, and customer support. I personally use tools such as Cursor all the time. I ask ChatGPT to help me ideate on code all the time. Coding has evolved due to the nature of data we've thrown in to large language models. Similarly, deep research is also a very is a set of tasks that are able to be solved by LLM agents really easily too. I phrase it that way because deep research can across a variety of verticals. So that can be finance, healthcare, science, math, etc. AKA the ability to say, hey agent, go search archive and Wikipedia and Google and aggregate all this information and come up with interesting insight is something that's really useful. And then lastly, customer support is something that's actually quite easily solved by agents too. Obviously, there's a lot of exploitative behavior by those taking advantage of AI agents. But that to say, the ability to read over usually your custom knowledge base, aka the documents that represent your internal FAQs and such to help customers as they come in with problems, that can be simply processed over by these agents also and given a human touch by describing the persona of that agent also. And so as websites work for internet and apps work to smartphones, agents are now becoming this core unit of interaction for AI. So where each agent has this type of pre-described behavior to do useful tasks. So yeah, I'll leave it there. And so I kind of realize it's a bit odd ordering to place the slide, but regardless, and these agents, the reason we have the word agents here as opposed to agent is that agents will also be interacting with other agents to create this complex behavior. Especially as in the future, as agents become serialized and we all, as a community, come to an understanding about how we want agents to look and feel like in such a way that we can share agents. Then we can start to build these really complex behaviors using orchestrated worker patterns, sequential pipelines, and parallel agents and such. And some frameworks to make these multi-agent patterns and single-agent patterns easier are popular tools such as LangGraph and LangChain, research-focused tools such as Autogen, or role-based tools such as CrewAI. So before I mention this phrase of horizontal framework, I want to just reiterate that here to say, for me, a horizontal framework is the tool that a developer would be using to scale out the development of AI agents themselves. And so this is very different from a vertical framework where that is more so, as it implies, vertical focus. So usually industries are now buying into um, agent platforms that have a lot of pre-descriptive behaviors of agents um, or utilize agents in some capacity to solve the common set of tasks for particular verticals. There are many tools and many startups that come in and go in this day and age around AI agents for verticals. So to reiterate, hopefully this was a good primer before we jump into some visuals and some code itself, that agents are easy to demo, but hard to productionize. The reason that this is true is that agents are prone to mistakes that human wouldn't make. They're non-deterministic and inconsistent, and they're complex and opaque. So they become not very easy to gain visibility on, especially as agents take a very long time to think. And you have this problem where one thought process can lead to many bad thought processes, where it's hard to isolate where actually the failure point is. All we know is there's a class of failures that start to occur as certain thoughts coalesce together, a particular task. So now we're going to talk about how to continuously evaluate and improve our agents after I take this quick sip of water. Cool. I'll hand wave this. Let's build an agent right now, or talk about an agent in production. Let's build a deep research agent. So how would a deep research agent look like? Here's one example of how I may architect this. First, I may have a search term generation agent, which will, given the user's question, create a variety of search terms that are compatible with whatever knowledge base I want to interact with. So in this case, it might be something like Wikipedia, where I'll be able to generate a bunch of search terms I can then send into Wikipedia to grab those pages. Then I'll go and get those pages using my get pages agent, where this get pages agent will grab each of those pages and make sure to throw away bad ones or just verify if these are appropriate before parallelly sending each individual page to different agents, all identical to each other, whose main job is to coarsen the not coarsen, it's which will go and summarize that particular page to its most useful information as it relates to the specific question asked by the user. Then also you may have something like an image evaluation agent, which looks over any images on that page to describe what's going on. And it aggregates all this information across each of these summaries from these Wikipedia pages and all the images from these pages, then generate a particular report. I will not dive too deeply into how this search term generation agent works. Just know in general, we're just searching a bunch of Wikipedia pages over the terms that we search a bunch of pages over. This right here is an example of our deep research agent. I might ask something like, let's see if it actually looks it up. What is the weights and biases? Okay. Hopefully this spawns appropriately. So cool. You'll see here it says starting with researching this query. And hopefully next it will then say searching for a particular set of terms. Oh, we love a live demo. That's okay. I do apologize for that. Regardless, As this is working in the background, actually, this is perfect for that. I noticed that this is actually taking a while, and now because I see this thing starting deep research workflow, but I was worried, as I was a second ago from this live demo. I would want tools to help me verify that things are working appropriately. So what you see now is the weights and biases weave tooling. You'll see here we have this research agent.predict going on here with this little call not finished symbol. Essentially what we see here is actually my interaction that's going on with this particular agent. So you can see here that this research agent takes in a particular set of details that I've programmed here. If I want to see what that looks like, I should go to my code tab over here to see the code state of this particular agent. Or I should go into this research agent itself and also see that same code tab here. In essence, I can see what we're doing here is using a research agent. Let me actually go in. Let's refresh this page. Maybe it goes a little faster. So cool. So you can see here, as my application runs, we can actually start to see the thought process of our agent itself. So in this case, we're using LangGraph as one of our agent frameworks. And you see here that the first thing it's going to do is generate search terms. So what's useful here is generate search terms as it's running, that's off null for now, is that it's going to call this particular tool by our agent to go find out what terms it should be searching into Wikipedia to then go ahead and actually do that summarization for us. And then to do all the other steps I mentioned earlier. For the sake of time, I'm going to show an older example. So you can see here that we have this generate search terms. I'm going to then page through my siblings, maybe. Yeah. So you can see here, we first generate our search terms, which you can see here that this output will have a collection of 4 search terms for the question of, tell me about the strains of COVID-19. It looks up these 4 different search terms. Then we'll go and grab each of these pages over here. So you can see here, given my input of these 4 search terms, I can then go back out here and see the pages I grab. So you'll just see that these are the same 4 pages that represent the same search terms. And then for each of these pages, we can see that we go ahead and actually summarize each of these pages. So given our input of that question alongside the page itself, the page is retrieved and a summary is then generated with a particular score. And that particular summary is also coarsened into a relevant summary, which better represents the question that was asked by the user. Where that question, again, was, tell me the strains of COVID-19. Then we'll go ahead and do that for every page moving forward. So you can see here that as I perform each of these actions, I not only get to see this thought process of every tool call and the thought process of our agent itself, I get access to any costs that are incurred by this LLM, the latency of the overall process to understand where bottlenecks are, and also if any problems go, I can go ahead and actually provide feedback. I can do things such as add annotations, write notes, add scores, or even just look at other useful components of this specific thought process by our LLM. So this can happen at the individual thought layer, or externally, I can add thumbs up or thumbs down at the input-output layer, aka the pretending the agent is a black box, where the black box is fully open over here. If you're ever confused too, there's also different tools to make agent interaction a bit easier. So what I find particularly useful is the trace view for all qualitative understanding of any LLM application, particularly the thought process of agents. The code view is useful for understanding the different tools that you're allowing available for your agent. So you have things such as generate search terms. I have the get pages call. I have the summary pages, aka understand really just like all of the see essentially how often a particular tool is called and see where it's nested within the composition of agent. We also have the flame graph view to actually visually understand any bottlenecks a bit easier. And we also have the graph view, which allows us to actually expand out and understand the sequence of steps taken by a particular agent to understand whether or not the flow of logic is appropriate too. So from left to right, we have generate search terms to get pages, to 4 different summarize page calls, to evaluate image, to generate report. So from top to bottom and left to right, we're able to understand essentially, are we unfurling this agent thought process appropriately as we've intended to design it for. So naturally, I can go in here and just say, and maybe take my word for at least this specific example. This looks good. Like I am happy with how this end result of this particular research agent has performed. And at the very least, I can qualitatively say, this one did a good job. But this is where traces become really useful from going from something like a UI form where a user asks a question and you as a developer want to dive in deep to find out where any particular failure modes may occur qualitatively. So then I did miss a piece, so I do apologize. Let me go grab that right now. Now, there's a particular piece I did not like that much right here. So let's say I didn't like this particular call to an LLM. Oh, sorry, I forgot to also show this view. This is our chat view. So this is actually also useful because you see the raw in back and forth between you and the LLM provider a bit easier. And so whenever you want to reload a conversation, it's also useful to build tools to reload a particular step from your agent thought process into a new playground, a new UI to see whether or not that agent would consistently have the same thought process given similar perturbed outputs, aka slight modifications for input, but hopefully the same sequence of steps occur. And so after reloading this, we can see that this is indeed what's happening. Traces allow you to qualitatively analyze. Playgrounds allow you to reload conversations with different model providers a little bit easier so you can understand qualitatively, given the same prompts, is my agent working appropriately? And also scrutinize the cost and latency of the agent itself to see whether or not it's worth it from a financials perspective or a metrics perspective on that end. But the next thing you naturally want to do is actually run systematic evaluation. So this is where you go from saying, I have 3 particular inputs I'm building my agent for, and luckily I can go and just create prompts for all of them. Now let's say your boss says, here's a CSV of 500 user inputs that we want to have 97% accuracy on. Now it's up to you as the AI engineer building this agent to one, define the success criteria of accuracy. So what does that really mean for this agent? And 2, to actually calculate that number itself. So you need to tractably find a way to go, instead of visually saying, this looks good, aka vibes-based eval, you now have to actually have a formula that formula that represents and calculates a score that tells us whether or not a particular agent is doing well at a per interaction level and then at an overall level. To say that this is actually quite difficult. Luckily, we can look at the standard ML world as it existed to gain some insight. So the standard flow, as you do with most evaluation, even when you're building these models, is you want to use existing production examples or generate synthetic ones. Then we want to have experts annotate any of our synthetic or real production examples. And then using that data set, which unfortunately you can't really escape, you're going to use that moving forward to then apply that against your agent with a standard scoring preset or framework, where you're spending time customizing and aligning what the scoring criteria actually is. An example of these is that you can use a collection of tools such as Ragus, or use as Ragus, for instance, to define how well an agent is doing for this question, context, question, context, answer triplet, where there's also a variety of really complex measures to determine how to evaluate agents. That's outside the scope of this particular talk. I could spend days about agent evals, but in essence, agent evals also incorporate layers of ordering and things such as the tool selected alongside how useful each step or thought an agent takes is to getting closer to a goal state. That's complex to do for now. Instead, we're going to focus on the global level of success for an agent, aka given some question and context, did the agent solve the answer appropriately or perform the final answer step appropriately? And this will hold true for most LLM workflows. So what we can do is generate our own data set, but then do some types of evals. What that may look like here is, in this case, I may want to do a comparison, for instance, between GPT-4o and GPT-4.1 mini. Let's say I'm happy with the current state of my model in production, which was 4.0 mini, and I want to make an upgrade. I want to understand whether or not 4.1 is a more appropriate selection for my end production use case. So what I have here is I'll have a relevance score, relevance pass-fail, accuracy pass-fail, execution time, and total tokens. This represents the collection of metrics that I will use as my success criteria against how well my agent is doing. And so you can see over here, all these green numbers represent that my agent using 4.1 mini is beating 4.0 mini across every measure, except for tokens, where it's using 36,000 more tokens. So in my mind, now there's a balance I have to make of, is the additional incurred cost by 4.1 mini worth the marginal increases of, oh, sorry, this one should also be red because this one's slower. So I do apologize. I'll mention that to the team. But for the accuracy gains, is it worth being a bit slower and costing a bit more? One thing I may want to do, though, is also verify whether or not I trust these scoring criteria. So now you go into this programmatic score section where you can see under assets, I've serialized any prompts, any code, any models and data sets, etc. I may, for instance, my new eval, which has this question query image, I guess. So they have a slightly different triplet. If we go to our programmatic score, we actually see what each of these represent. So for instance, accuracy. What's going on? Okay, over here. If I go to my accuracy score over here, which over here, accuracy summarize. No. Accuracy score. Yes, so you can see here, for instance, here's how I define this particular scoring mechanism. So over here, what we're actually doing is our scoring mechanism in this case is using a separate LLM as the scorer for a new one. So in this case, I'm using a Claude model to look at the inputs and outputs of my agent and determine whether or not it is doing well. Luckily, we're able to do this because we can do things such as use tools such as instructor or structured outputs to force our answers to be conditioned to have the similar output every time. So earlier I said that agents, LLMs are non-deterministic. You don't always get the same input for every output. You still cheat the system a little bit by using very clever packages and tools which allow us to form fit our LLMs to behavior that we prescribe a bit better. Also outside the scope of this talk, but in essence, you can mean if one thing to take away is that a appropriate scoring mechanism is using another LLM to score your agent application, with the caveat that you are being really prescriptive about how you define these scores and how you define them and how you parse them. And use them downstream to represent the success of your agent itself. So in this case, we have a collection of workflows to qualitatively analyze how well an agent is doing, a collection of workflows to understand how well quantitatively our our agent is doing. Now that all that's left is to just release our application to the world, ensuring that we're monitoring things such as calls, costs, tokens counts, any feedback by users, and then gathering any feedback from users directly also in the UI you build. So okay, ensure that you're always adding user feedback, as that allows you to simplify the dataset generation piece that's essential for running quantitative evaluations. And moving forward, pieces tend to fall into a bit more, I'm gonna skip some of this stuff, into like a natural workflow. So you have your initial application being built where user eyes to verify it works. You create some numeric quantifiable metrics to prove to any stakeholders that it's worth releasing. And you monitor those scores. You monitor the production and the application of production. And at a certain point, when you're ready to upgrade or improve the agent, you can then take all of the insights that were gathered in production step. Oh, sorry. Bring it back to the evaluation piece qualitatively, and also use those same examples to be the new data set or augment the data set, which you'll run these scoring mechanisms over. So if you can see that your data set will evolve as your application evolves, and you also see that your scoring mechanisms become more of that foundational piece to help you determine whether or not certain adjustments are appropriate to make. So adding rigor into a a free spirit LLM is extremely useful. And that's what these types of tools are these types of workflows and tools are useful for. When you're improving agents, it's all about doing more of the science and not the fiction piece, even though the fiction piece is way more fun to build around. Ensuring you have the right tools to do all of those steps. So I recommend trying out weights and biases if you want to get started with plugging in any of these, trying to actually peek into the thought process of agents, as we have a lot of great integrations for all the frameworks mentioned. And also reach out to me if you want to learn more, as we talk about agents all the time. I specifically have worked with the OpenAI team to help create a course around some more of these deeper agentic concepts. Also, for the rest of the week, I'll be having more talks tomorrow and Thursday in person around agent workflows and building multi-agent patterns. But with that, I'd like to thank all of you for this hopefully not too crazy deep dive into architecting and orchestrating AI agents. And if there are any questions, I'd love to answer them now. Thank you all.
So I will start with the latest one, which says, does OneDB work to evaluate LLM queries in platforms like Snowflake and the AI complete functions?
I have not worked particularly with the Snowflake team on this. If it's within the notebook tooling or within the actual application itself, it would not work. Weave and WanDB are particularly for those in development space. So if you're using Python, TypeScript, and you want to observe you actually building that out, then that's where weights and biases and Weave would slot in perfectly. So if you're building model applications in a Snowflake notebook, for instance, in Python, throw in weights and biases Weave. They'd work perfectly together.
The next question is, how do you prevent one agent from sending wrong information to the next agent? Where does human oversight fit into agent development?
Fantastic question, Nicholas. And I think your actual second question already hints on the answer to the first one. A lot of ways to prevent one agent from sending wrong information is to actually have human in the loop workflows. So for instance, if you're using any of these code-based IDEs, for instance, before it runs code on your behalf, it asks you yes or no, allow. So in critical operations where there's multiple agent steps or particular tools you don't want to have wrong information sent down to, you'd ask for verification from a user or a human itself. Unfortunately, though, there's no way to prevent an agent from sending wrong information. All you can do is use tools such as structured and structured outputs alongside having in between tool steps to read the inputs and outputs for each of these agents to ensure the contract of information is still valid. AKA, you can do is prevent like a float being sent in over to something that expects text and whatnot. And that's more standard software engineering principles.
Next question is, in a multi-agent system, how do you handle reliability and accountability? For example, if an agent malfunctions, stops responding, or produces a diverged results, what architectural or observability mechanisms do you recommend to ensure traceability, explainability, and auditability across agents?
Not to shill for weights and biases too hard, but I do recommend weights and biases quite heavily. We've been in the space for a very long time, helping folks in the foundational model space and now the AI engineer space do exactly just what you mentioned. But in terms of how to deal with this multi-agent system problem, um, it's a difficult one. I think a lot of standard stopgaps I've seen from companies is to look for how long an agent takes and to kill responses that take too long. I just apologize for the thumbs up emoji this happened. The second one that can also be done is preventing amount of steps that an agent can take. So for instance, a lot of frameworks that you'll see will have a timeout clause and also have a number of steps allowable clause. Similarly, you can also have tools that exist that help agents scrutinize itself. So for instance, I've seen something like a scratch pad tool, and once a scratch pad gets overfilled, an agent is told to flush itself, aka stop and ask a user to continue after reading that scratch pad. So it goes back to really how you would architect your system. But luckily, a lot of frameworks just allow us to do things such as add in purposeful weights in the appropriate location. So you're not just beating up the LM model provider and accruing crazy costs.
Next question is coming back to the human in the loop. So can you talk about human in the loop for crew AI?
Yeah. So unfortunately, I actually haven't used CrewAI's inbuilt functionality for human loop stuff much. I have used a mixture of what I just previously mentioned, timeouts and number of steps allowable by my agent to incorporate places where I would come in and allow an agent to like perform an action, for instance.
Next question is, does OneDB have any plans to offer pipeline service like Opal or N8N?
Transparently, I'm not super familiar with those tools myself. All I know is right now our main focus right ahead is definitely for those who want to build like auditability, tracing, and valuation into their tools. But with our great leaders at CoreWeave, who knows, the sky's the surface for whatever we want to build out there.
Next question is, would you consider multi-agent orchestration an application-level form of mixture of experts? And if so, how should we think about the trade-off between model-level routing inside mixture of experts, architectures, and systems?
Oh, this
System-level
is
tasks. Yes, I think I'm reading that part, right?
yeah, the one very wordy question. Two, I like this one. Yeah, this is an interesting thought. I would say that you are on the right mindset, Amit. However, I would argue that MOE is more aligned to one paradigm of a multi-agent pattern. Multi-agent systems can be very diverse in how responsibilities are shared across different agents. And so in a mixture of experts way, it's more a particular user's input would be routed to the proper expert, which would solve that particular question. In a multi-agent system, it is not always the case that you're routing a user query to the right agent. It could actually be that you're still using the same agents always. It's just certain agents are never called. And so in that case, it's more the system itself is understanding the intention of your question and is implicitly calling the right agents, which is a form of routing, but I would say it's a bit different about than how routing is done in an MOE style of way. I do think both of them have a lot of overlap. So you can take the initial routing thought process and incorporate that into how you design your multi-agent system and then the prompts that represent how you imagine routing in your multi-agent system. Great question, though.
Next question is, what are the guardrails for your textual task definitions? Against what specification do the tasks get measured against?
I think I'm a little confused about what you mean by textual task definitions. Uh, but I guess in my sense, guardrails obviously represent a protection layer against malicious behavior that comes from either users coming in or responses coming out from an LLM. And so, in our sense, how we build guardrails are not as what we do is you can define, for instance, a separate LLM, which can go ahead and read the output of the LLM that you're trying to guardrail for. And that one could be one that spits out whether or not something is malicious, racist, biased, etc. You can have a normal package, which is literally a list of curse words that are not allowed. And that can be, for instance, the spec in which the output of LLM is that all that text is just mapped against that particular text of bad words or that PAI tool you use, aka, at least from the leave and wait device side, we don't have any particular way we force how you should interpret guardrails. How to block for text reasons is as simple as how you would block. Not simple. It's identical how you would block text currently. So use a mixture of those PAI tools, anti-bias tools, and other LLMs. Hopefully that answered your question. I do apologize if I misunderstand it.